Okay, we good? We live?
Yes, we can start.
Okay, we've completed placement. Utilization is really, really high. But for some reason, congestion is low. Setup is bad. Why are we checking hold after placement? Whatever. We don't have a tran, we don't have a cap, we don't have a fan out issue. No, we don't need to upsize every gate. So what would we look for here? Should I be answering these questions or should I just go straight to the solution? Okay. No, we are not upsizing every gate. That's this answer.
Yes. And
No.
why?
Okay. Okay, that's the next question. Why? Okay. Why? Because I mean, this just looks like we don't have congestion, we don't have tran, but I just have the hint that upsizing out this gate, the only thing it guarantees is more power, more more power drawn, and it may not necessarily fix some of the issues that we have. Um, but I guess we'll get back to it in a minute. But I think I think that there are better ways to fix it. That's probably why.
Mm, okay. So you are saying we will not upsize all the gates because we might hurt with respect to power.
There's that. There's the power congestion, probably possible congestion as well because the utilization is high.
Hmm.
So that's not what I'll be trying to do first.
Okay. And what should be the answer of second question?
What are the risks of binding? Yeah, there's congestion. There's more power usage. Um, because the utilization is high, right? More power
Hmm.
usage, like congestion may increase. Uh, that's why. And the other reason, like I feel like there are other things that are wrong with this timing. But so before I get to the conclusion of upsizing, I want to confirm a few things before I decide to upsize.
Mm-hmm.
Because the utilization is high, congestion is low, but we still have like really, really bad WNS. So um is to sit down and ask like, is there anything causing it besides that? Is it maybe they don't you sell? Is it maybe some other thing? So I'm just looking at it. You don't just
Yeah. So whatever you are trying to say, that could be answer of question four. Okay.
yeah. Yeah, okay. What would I analyze? What will make me say, okay, this one needs to be upsized, this one needs to be downsized? Maybe depending on the part, if the part has like a drive two cell driving like a drive eight cell, maybe some of those could be upsized, if it was that. But then you may not have a tran issue, and even tran issue that depends on if the tran limits are set properly. This is probably why I may not want to upsize because we don't have much of a tran or capacitance or fan out violation. So that's
Okay. So if
probably
we upsize any cell, why tran violation will come?
no, not that tran will come. I'm saying that typically we tend to do upsizing when we have like these issues, tran, capacitance, or fan out. We tend to do upsizing and splitting, like load splitting, but we don't have any of this. So it's either our constraints for these are not set properly, or they are set properly and it's probably not a tran issue. So that's what I was saying, that if I was going to upsize something, it's either something is driving a huge buffer or a long net, but it's which basically should show up here in the transition and the capacitance, but it's not necessarily showing up. That's the only reason why I would say, okay, let me upsize a cell.
Right. Yeah. So not see
Hello,
you. Yes, Obul. Yes,
Jignesh.
you are audible.
Hello.
Mm-hmm.
Yeah, I can hear you. Yeah, previously I am not able to hear. So yeah,
Okay. So yeah, Jignesh, those were my answers.
Correct. Yeah, and one thing is see, basic right in placement stage. Generally, we are not doing manually upsizing the cell. Okay.
Yeah.
Right. Our first goal is to understand the root cause, like why we have timing violation. What could be the possibility?
Yeah. That's what I was going to say, that, I know all these questions are here, but for me, the first thing is, when you look at time evaluations, it's why. And try to say, okay, what can we do? Should we do like some form of part groups and give them more weightage or something?
Fine. And 5 number path, a 5 number question.
How do I verify that my optimization improved the design? Um, okay, first you see the timing stuff. The report timing is done. The congestion as well. Like, did it go through the roof? Did utilization become bad? Um, I think those are the things that I would consider. You know, if anything improved, the utilization, the congestion, the transition capacitance violations, if for any reason they they degraded. So some of those things I will check.
Right. Okay. Basically, the metrics which generally we are checking at after the placement, right? That we
Yeah.
should check.
Yeah.
It should not happen that yeah, if you fix one path, but it leads to create other path violating.
Yeah.
Okay. Let's scroll down.
and these questions are from where, Jignesh? From whom? Like, did they ask it in interview?
Yes.
No. These were somewhere randomly on the LinkedIn. Okay.
Oh, okay, okay. Yep.
Also, this gives me an this things looks like parts may have huge logic depth. That's something I'm thinking of. But yeah. So trade-off is that. Congestion. Okay. Congestion low. Try low. Yeah. I need logic depth.
Right? Yeah. See, this is very interesting question. So you mentioned this thing only, Jamie, right? Wrong combination logic depth.
I didn't really mention cell swapping. I mean, I thought it was maybe like don't use cells.
Yeah, that is possible. Let's say in your design you made if all the LVT cells don't use, so tool has to use HVT only.
Yeah. Or maybe it's even used a cell that has terrible delays.
Right.
Maybe.
One question, Jignesh. So when we are doing the report congestion, right? So in
Uh,
current project, I am seeing like horizontal vertical congestion, which is like point zero 0.02. Okay, like that I'm seeing very
mm.
small numbers, which is not congested. But when we are checking in the layer wise, let's say like one of the layer having overflows more, like M6 or M12, maybe, yeah, M6 I guess. Also, and in the log file also, in the placement stage also, it's mentioning so and so coordinate you have congestion hotspot. So at the time, like, should we try to increase the, like, what should we do, like, as we have metal layer congestion?
Yeah, see, congestion will always because of metal layer only, okay? Because your routing will happen, and based on routing only, congestion will be decided, right? How many active tracks are available, and how many tracks tool required for routing. Okay.
That's correct, but overall numbers are very very less, right?
Yeah.
So
Now
uh,
you need to understand one thing.
uh,
In ICC2, when you say 2% congestion,
uh,
that is saying that 2% GRC is having overflow across all the GRCs.
okay, all the years is correct.
It is not saying that two is extra track required. Okay, demand minus supply. That is
uh,
not the two. Okay,
Correct, yeah,
basically two is not overflow. But in
2%.
Innovus, you need to understand because there, if you remember, when you say hotspot, it is basically the overflow only. Okay, demand minus supply difference.
Correct, Jignesh, yeah.
So it
If
is possible. Yeah, it is.
if we have some, like, saying only one layer is there and the remaining layers are pretty good, so then we need to understand why do we have more cells are going in that area, or like, should we try to change the layers, or like change the layers means like we can give the max layer and min layer for the routing, right? Like for a few, so that
Yeah,
way
now
we.
see, generally this layer promotion, okay, layer
Mhm.
promotion or layer demotion, that tool
Mhm.
only does depending on the other criteria, okay, timing, congestion, and all.
Okay.
But if you have given some constraint, let's say in one region you have only all the routing blockage you have given, only metal 3 routing blockage is not there, okay. So tool
Uh-huh.
have to have route in metal 3 only. And if all the tracks are used of the metal 3,
Uh-huh.
then of course you will have overflow, right? Tool need to use extra routing as well. So you will see more hotspot, okay, very bad hotspot.
Got it. Yes.
That could be reason. Other could be, let's say, you have one block here, block A, okay, block B, and block A, and block A, B pins are connected like this is
Mhm.
okay. Now let's say pin is metal 6 and this is also metal 6, so it can
Okay.
directly connect vertically, right, in metal 6 layer.
Uh,
If you added a here routing blockage of M6, that
uh,
means you have zero tracks available of the routing.
uh,
In zero track, tool need to route all these metal 6 pin.
okay.
So that may not be, I mean, tool will consider it is overflow because available track is zero, but need to route more track. So that way you will see very not realistic hotspot number.
Got it. Yes, I understood now this point. Yeah. Mhm.
Okay, fine. So yeah, I think this possible root cause we discussed: logic depth, VT. Okay, now this point is wrong. Okay, in placement we are not checking skew and latency.
Nope, we're not doing that. Of course, we know that placement quality, interconnect delay, just TLU plus file. That's probably a reason. But like you said, before changing cells, you have to investigate the actual bottleneck. That's what I'm saying. It's not a good solution. You know, you kind of need to know what's really happening. Just optimization should target the root cause, not the symptom. Exactly. Now, no upsize gates on critical paths. Again, you have to know what's really causing the issue, not just blindly treating symptoms. Upsizing of critical paths, higher dynamic and leakage power cell area, and potentially increasing congestion. Yep. These were mentioned. High input
Right.
capacitance, new node violations, routing challenges.
Now, yeah, this also may not be right thing. Hold violation. Replacement, we are not checking hold,
Mhm.
so it's not making sense.
Before you do that, you would have done timing reports. Yep. You would have looked at the cells, the nets, slack distribution. Yeah, fan out and load capacitance. This was one that I was trying to say. Congestion, possibly. Yep, you have to look at that and power
Because
impact.
congestion is might depend on the. I mean, congestion and timing is related. Okay,
Yep.
so we need to understand. Let's scroll down.
Buffer insertion. I think I did mention this.
Uh, But just need to remember, we are at placement stage, so we are not manually adding buffer.
No, we're not.
Uh,
We're not. We're not. Which is swapping. I don't think we do all these ones at placement stage.
Yeah, that is already done by the tool itself.
Yeah. Cell relocation. Maybe probably with bounds. But
Yes.
even then, depends on what the cell is. But yeah, I'm not sure we'll do all this useful skill here. This is more of CTS thing. I don't think we can only change the TLU plus file here. Maybe we don't really do optimizing of routing. We don't do ECO here definitely. Yeah, we can do some constraint review. We definitely can do this. So let's see. We don't really do this. We don't really do this. We don't really do this. Don't really do this. This is like a half. This is like a half. So actually, it's more of TLU plus file change. No, we don't do this. And we definitely do this. We definitely do that. So yeah, that's it on this one. Okay.
And so, okay, scroll down.
Are we doing FTA already? Okay. Check would ensure that yep. We answer this question power area and congestion reports. We don't have any DLC. We may not be able to see that. I'm not sure we'll be able to do this as well.
Okay, fine. So yeah, this is the next question now. You are at route stage. Just scroll down. Okay, don't go to the answer, but yeah, till scroll down till the question itself. Scroll down. Mm, Down further. Mm.
I think this is it.
Okay. Do you have question two? Just scroll down. Let's see. Okay, good. Question two is also there. Yes. Okay, fine. Yeah, we'll stop here. Yes. So, Channa, basically we are discussing some questions, scenario-based questions, and you just need to try to share your view. Okay.
Okay.
So yeah, try to read this line and then maybe try to give answer of this first question. Let's see.
Showtime.
Okay. I think first one is not it's not a appropriate solution to add just insert delay buffers on every whole path and tape out, because if we add delay buffers simply, then it might violate setup. So we need to check the setup if we want to add delay buffers, and if whole violations get fixed, then we also need to check setup if it got violated because of adding delay buffers.
Right. Good point.
Okay.
First one is that
Second,
is adding delay buffers. It's not always the best solution, and because yeah, as I mentioned for first one, it might violate setup if we add delay buffers on every whole path. So
then which other solution we can suggest for hold fixing?
um, we can we can increase the length of the net, but it might, yeah, we can increase the length of the net, or
Okay, and how can we increase the net length?
maybe by routing in a different direction. I'm not exactly sure, but if if the routing takes a different route, then the length might increase, right?
Okay, fine. So yes, that is one possible other alternative. What about third number question?
Disadvantages of inserting too many whole buffers. Uh, so it might violate setup because data might arrive late on the same path. As setup slack is margin is very less, 25 picoseconds. So if we add too many buffers, then delay will increase and setup might violate there.
Okay, so one risk is setup violation. Any other can you think of?
Area will increase there in that path, and power consumption will increase.
Okay.
Yeah, delay, area, and power will
Hmm.
increase.
Fourth number.
What reports would you check before deciding where to add buffers? This timing reports only if we what is the setup margin, to see if setup margin is in reasonable range to add too many buffers before adding those many buffers. If the margin is very less, we can't add too many buffers.
Mhm.
So
Okay, and
timing
fifth
report,
one. Mhm.
can hold violations be fixed without adding buffers? If yes, explain at least three methods. Yes, we can downsize the cells. That is one method, and can also use HVT cells. We can swap the cells with HVT.
Okay.
Second one and third one without adding buffers using a long net, as I said before.
Okay, fine. Let's scroll down. Okay, let's see now answers.
Okay.
We have one more question.
After fixing hole, what would you verify before declaring the design is ready for sign off? We have to verify setup for sure, and we have to see if there are other violations because of, after fixing hole, like the violations that were given above, transition capacitance, DRC, all those EMIR also. I think I'm not sure if we need to check that all. I think we need to check that one also after fixing hole.
Okay, so let's read one by one answers. Okay, at least you will get idea now. You can try to compare with your answer then.
Okay.
Showtime.
Okay. So we need to analyze each and every path where there is hole violation, not just blindly applying the same solution for all violating paths. For one path, they might need different fixing. For other paths, they might need different fixing. So based on that, we need to apply. Analysis means okay.
Right.
Yeah.
Okay. Scroll down.
Yeah, blindly inserting buffers means it can consume unnecessary area, increase power, dynamic and leakage, increase routing congestion, introduce new DRC issues, and reduce setup slack. Yeah, and unnecessary ECO complexity means what, Jignesh?
Yeah, if you add buffer, so you need to place it, you need to route it, right? The
Mhm.
routing and so that is complexity only.
Okay. I didn't mention. Yeah, I mentioned about area, but not routing congestion. Disadvantages. Yeah, okay. And
Scroll
DRC.
down, Jamie.
Yeah, with minimum design impact.
For example, by VT, so if you are able to fix the port, right? By
Yeah.
SVT to HVT, you
Mm.
prefer that one only. So it will not have any ECO complexity.
Mm. Okay.
So it looks like okay.
We need to swap with HVT, right, Jignesh? Because HVT
Yes,
cells are
that's
slow.
what I mentioned, right? HVT to HVT.
Okay, I didn't hear that. Okay. Next one.
This is a very good point here.
If false paths are synchronous
The
paths.
question is, should the path even exist in the first place?
What, Jimmy?
This one is basically you wondering, saying, okay, if we have a path that is failing timing, should the path even be valid in the first place?
Okay. First, we need to check if that path is actually valid.
Yeah,
Okay.
I mean, if
Yeah,
it's
if
not,
that is a false path or asynchronous path, then no need to fix at all.
just go to your
Okay.
constraints. Yeah.
Asynchronous path means what? I know about false path.
Chandana. Okay, I'm not going to say anything. Let's move on.
Okay, sure.
Yes, if you're adding buffers, what you will check and all. So that, yes, right?
Yeah. If it is extremely short data path, then buffer is good. Please scroll, Jamie. Area will increase.
Really? Just area?
What, Jimmy? I can't hear your voice properly.
No,
I
it's
think.
fine. It's fine. I'm expecting more than just area.
Okay, I said other things also. Power and
Aha, this is the one I was looking for.
okay. Yeah, it can also reduce setup slack. Okay. You can scroll down. Longer ECO runtime.
So yeah, I think majority point Sandhya mentioned runtime, then increase design complexity. Okay, go down.
What reports will we check? Okay. Violating paths, hold slack, path delay, launch capture clocks, setup timing. Yeah. Hold setup.
Yeah.
Clock timing also.
Yeah, I was gonna say that we haven't checked the clock skew when we are doing routing. We should probably check that.
Okay.
Okay, so launch clock arrives at 0. Capture clock arrives at 180.
180.
But the data part is pretty much just about 20.
He is 180 basically.
Yep. Yeah, hold can be due to excessive positive skew on the clock. Chandana, do you understand this?
So here excessive posture skew means the difference between launch and capture, right? There is 180 difference, 180 picoseconds.
Mm-hmm.
But the data arrives at 20 picoseconds.
Mm-hmm.
Okay. And capture clocks arrives at 180. So there's a difference of 160 picoseconds.
Yep.